Hello and welcome to the video demonstration of the TIE Asset, short for Threat Intelligence Integrator. My name is Esteban Armas, and I am part of the Auto Spain team. TIE is a tool that enriches the data received by the cybersecurity team to improve its performance and better protect the business against external threats. The TIE Asset is developed to address the challenges in the field of cybersecurity at all business times. TIE's design and development provide a solution based on standards and platforms widely used in the field of cybersecurity. In addition, its heuristic engine allows adjusting the enrichment of information in a tailored way for each business. The benefits of TIE in any business are, among others, the easy integration with external monitoring tools, its ease of use, practically transparent to the user, and above all, the support to the cybersecurity team to make decisions on the prioritization of defense actions against cybersecurity threats in the business. The components that are part of the TIE Asset workflow can be divided into three parts. The first part is the external sources of information that are synchronized with the MISP instance of the TIE. The MISP instance of the TIE is responsible for receiving this data and acting as a communication bridge between the heuristic engine, the instances that consume the TIE information, and the external information sources. The second component is the TIE itself. In the diagram, we can identify the internal components that enable the TIE asset to function. Once the data from external sources arrive at the MISP instance of the TIE, they are automatically sent to the heuristic engine to perform the analysis and generate the risk score for each of the new events. This analysis is performed considering 5 characteristics: accuracy, completeness, relevance, timeliness and variety, and the specific topology of the internal business network. For this, an inventory of each component that connects to the network is necessary. The third component is the instances that consume the information generated by the TIE and stored in its MISP instance. The events processed and enriched by the TIE are updated within the MISP instance of the TIE, and through synchronization between MISP instances, the enriched events are consumed. Synchronization can be performed through various methods that MISP allows. As mentioned above, the TIE uses the information of each of the nodes that make up the topography of the network it protects. For this, it is necessary to have a database that details the characteristics of each of the nodes, following the structure shown on the screen. The information required, among others, are the names of the applications installed or used, their corresponding versions and keywords that are considered important to use when evaluating an event. For the following TIE's demonstration, we are not going to synchronize with any external instance, but we are going to use events previously downloaded for this purpose. For demonstration purposes, in this first test, the TIE is not running. As can be seen, the event has been loaded in the MISP instance, but there has not been any change in its content. Now we will execute the TIE so that it begins to process the new events that arrive at the instance, and also those events that are placed manually in the 0M queue of MISP. Once we have our TIE running, we proceed to publish the event previously uploaded to MISP's 0M queue. As you can see, the event has been processed, and the system has added a label that contains the calculated score and also includes an external attribute that contains the calculated score as well. Returning to the terminal where the TIE was running, we can see that an event has indeed been processed, and that the score is the one shown in red. Next, and with the TIE running in the background, we will upload more events to our MISP instance. From now on, each of the events that arrive at the instance will be automatically processed, without the need to publish in the MISP 0M queue. In the TIE terminal, we can check that a new event has been detected and that its corresponding score has been calculated. In the same way, in the MISP dashboard, we can check that there is indeed a new event, and that it already contains the label indicating its score. Next, more events will be uploaded, and at the bottom of the screen, you can see that every time an event arrives at the MISP instance, it is processed by the TIE. As we have seen, the TI asset enriches the MISP event and converts its threat score into a reference for the company's security team to attend to those events that pose the greatest risk to the internal network. In this way, resources and time are prioritized. Thank you.